So this is after the ratios and weights quiz, and I'm still seeing a lot of confusion in, I don't know what just happened there. I'm still seeing a lot of confusion in the concept, which kind of surprises me because it seemed like in class we were getting it, but a lot of people are not showing me they understand based on the quiz results. There were some good quizzes, certainly better than the last quiz on the naming points, lines, and planes. But there's definitely some students that are not getting it. So I'm going to do a quick video. I'm also going to do a couple of updates, just general stuff, so that I don't have to spend as much time in class. First, though, got to just go over the main concept behind ratios and weights, and the biggest mistake that I'm seeing. If I have a ratio, I give you a ratio, and it's 3 to 1, we'll say. And I'm going to go over another thing that I didn't go over in class. I told you it wasn't going to be on the quiz, but you do need to understand it. But the way we learned about ratios, if I have a line segment and I have points on both ends, this is saying that we want to split that line segment into a ratio of 3 to 1. It is about length. A ratio is about length. So I would put a point on this line, or try to put a point. I don't have any numbers. Some of you tried to put your own numbers in there, which is actually okay if you do it correctly, and not many people did it correctly. But without numbers, I'm just basically saying, well, the left segment, and again, I'm going to change this later. So for right now, just we're talking about the left segment and remember, a ratio compares two parts to each other, not a part to a whole like a fraction, but two parts. So the left segment would be the 3, and the right segment would be the 1. And when I create this point, which again, I'd just be estimating without numbers, but when I create the point, so we'll put it in black, we'll say the left segment after I put the point on the line should look like it's about 3 times longer than the right segment. That's what those numbers mean. The 3 is how long the left segment is in relation to the 1. So just estimating, oh, and we would have 4 total parts. So that's where the fraction came in a long time ago. I could actually pretty easily do that whenever it's a 3 to 1, because if I divide it in half and then divide that in half, that creates 4 equal parts. And I'm just doing that eyeballing it, but that's pretty close. Dividing it in half creates 2 equal parts. And then if I divide both of those halves in half, I get 4 equal parts. So now the left segment, once I put my final answer, again, I haven't done an answer yet. I'm just thinking through the problem. I needed 4 equal parts if I'm going to use ratios and not weights. 4 equal parts. We'll say this is A and this is B, just so I can talk about points. So the segment, and we'll say I'm putting point C on the line. And there could be also, ratios have nothing to do with how many points are on the line. There could have been 100 other points on here. Like there could be points all throughout this line, all over the place. And some of you got confused when there were certain like other points that were already on there. So it could be M, N, O, P, Q, R, whatever. Those points could all be on there. They don't mean anything. We don't count points. We're not saying, oh, well, there should be 3 points on the left and 1 point on the right. Some of you did that because the number of points happen to match up with the number of parts. It's about the length of these segments. So when I go to put this point C on the line, I need to split this line into a ratio that is about 3 to 1. The left segment should be about 3 times the right segment. So I've already kind of split it up. I'm going to erase it. I'm going to remove that one because that should really be where C goes. So point C, I'm just going to write it really large. I'm still going to use black. That would be point C. Because again, if I look at the line segment, the left line segment. So if you want to use actual terminology or notation, AC, line segment AC, is about 3 times bigger than line segment C. Oh, I did not mean to use blue. Wait, why is it blue? I just hit green. Huh, that's weird. Try that again. Oh, didn't mean to do that. Hold on. Really weird. Red, go back to green. There. So if I look at line segment AC, and we're going to do that in a second, it's going to be about 3 times longer than line segment CB. So there's CB. And then what I do, blue, here is AB. So that blue line is about 3 times longer than that green line. That's what a ratio means. Points M, N, Q, P, R have nothing to do with it. I was just giving you on the problem on the quiz, I was just giving you multiple options to choose from, and you had to pick the option that made sense. Because some of them didn't, well, all of them but one didn't make sense. There was only one point that made sense if you understood how ratios work and how weights work. So again, last time, ratios are about length. This is telling me that the left segment, so in this case, once I put point C on the graph, because that's kind of how it read, put point C on the line segment, AC should be, so that's the blue segment, the highlighted blue, should be about 3 times longer than CB. That's what ratios mean. If you don't understand that, you got to come to me, because there's no other way. Sorry, you can watch other videos, but it's going to be the same thing, I have a feeling. So, all right, now let's go ahead and move on. Now let's talk about the difference between weights and ratios. A lot of you, and I'm going to kind of erase all of that, but you can always go backwards. I guess I'll just erase all of it and redraw some of it. So a lot of you put this or said this or something if it was an explanation question. We'll just use 3 to 1 again. You said, well, if the ratio is 3 to 1, that means the left side is weighted 3 times as much as the right side. That is completely incorrect. Weights are not the same thing as ratios. They're actually opposites. A ratio has to do with lengths, like we just said. The weights has to do with which point is more important. So again, if we do A and B, we just showed what this would look like. It would mean I would have a point somewhere in the middle. That's not a very good job, so let's make it a little bit better. So about the middle would probably be about there. Yeah. So that would be about the middle. Then I would divide that in half to split it into 4 equal parts. So using a ratio of 3 to 1, I've kind of split it into about 4 equal parts. And that would mean, I'm going to highlight again. That would mean this is the point right here. This, I don't have I guess I can put point C again. So point C would be about here, because that splits that line into a blue segment that's about 3 times longer than that green segment. Now, hopefully you remember weights are telling you which point is more important. So you can't say point A should also have a weight of 3, because that would make it way more important. It would pull the midpoint. So this is about the midpoint. If that's the midpoint, and A was weighted 3 times more, it would pull that midpoint in that direction. It didn't. Point C is right here. So clearly it's not pulling it to the left. It's actually B is pulling it to the right. That's why we have to reverse the weights from the ratio. So again, ratio is about length, weight is about importance. If you have a ratio and you want to then refer to weights, you have to flip it. And the opposite is true. If you have weights, but then you want to, and this is what probably more people did. I'll do another example in a second. So you would say that B is weighted more heavily because if the left segment is the blue segment and is longer, and we put point C right here, well, then B is the heavier one. It pulled the midpoint that direction. It pulled C from the middle more toward the right. I'm going to do one more, and I'm going to start with weights because I think that's probably the more common thing. So if it says the weight of A equals we'll say 4, and weight of A. So A has a weight of 4, B has a weight of 1. So A is way more important. That does not mean, and this is what a lot of people did, they said, okay, well, the ratio then is 4-1. That is completely incorrect. It's actually the opposite. Again, if A is more important, and I'm going to suggest you guys always start by putting where you think the midpoint is. So find a point as close to the middle as you can and say, okay, well, that's the midpoint. Midpoint. Or at least think about it in your head. So if that's the midpoint, and A is way heavier in this case, 4 times heavier, it's really going to pull that midpoint to the left. Well, how far left is kind of a guess, but it needs to pull it. If you understood ratios, it would make the right segment, so let's just say it's somewhere here. The right segment would need to be 4 times longer than the left. Again, the ratio is not that. We can't just make the weights into a ratio. We would actually have to flip it, just like we did when we solved the problem, which most of you actually did pretty well on the coordinate plane problems. I guess because we spent more time on that. But the ratio would actually be 1-4 if the weights are 4 and 1 respectively. So now just to kind of show you, I'll highlight again. So now the left segment is that long, the right segment is that long. So A pulled the point to the left, so we'll say C again. Oh, didn't mean to do it that way. So A pulled the point to the left. So again, if this was the midpoint, it gets pulled to the left, just like this arrow is saying. Well, if you now think about it, and again, there could be multiple other points on there. Those points are not, you don't count points. Does not mean there's 4 points on the left and 1 on the right, or 1 on the left and 4 on the right. Has nothing to do with how many points. Weights have to do with how important point A and B are. A is way more important, so it pulled the midpoint left. Or if you want to reverse it and do ratios, then when you put the correct point on the line, the left segment, so that's this, the left segment should be much smaller than the right segment. The right segment should be 4 times as big, actually. Or you could say the left segment is 1/5 of the entire line, AB. So AB and CB were our 2 segments. CB should be 4 times bigger than AC. If you want to talk about ratios. Again, a lot of you are trying to use ratios. I think weights are easier, at least for the math part, but you do need to understand the ratios if you're going to go back and forth. I don't know what else to say about it. If you're still struggling, you need to come see me or go to G2. Again, just the key point, you cannot just take the weights. If A is the left point and B is the right point, you can't take the weights and make this a ratio of 4-1. That is not correct. Cannot do that. We have to reverse them if you want to make it a ratio, which would mean that the left segment would be much smaller than the right segment, as we see down here. All right, so let's see what else I wanted to go over. Oh, clearly label your work. A lot of people are doing a little bit of work, or they're doing a lot of work, but they're putting it all over the place. I have no idea what problem it goes with. You got to be clear. I'm not going to look forever for work. I got 100-something papers to grade. I can't sit there and spend 20 minutes trying to find your work. You need to very clearly write problem number 1. Here's my work. If you need another sheet of paper, I got plenty of paper if you don't have it. But a lot of people maybe should have gotten some more credit because they understood it better, but I can't figure your work out. So if you're doing your work, or if you're not showing your work clearly, then you might be losing points. So just clearly label your work, clearly label your answer. A lot of people didn't clearly label their answer. I didn't know which answer went with which problem. So clearly label your work, label your answers, write the number of the problem next to your work so I know which one it goes with. I kind of talked about this again, when you're dealing with line segments and putting a point on a line with ratios or weights, or when we do midpoint, you'll definitely have to do it in midpoint. Start with the midpoint. So if you have a line segment, whether it's got numbers or not, just think, okay, the midpoint would be somewhere about here, because you're going to wind up using that in some way most of the time. If you have numbers, so 6 and 14, go ahead and put a number with it. Say, okay, well, the midpoint should be halfway in between. So what would halfway be? Well, and there's a formula for it that we'll go over, but it needs, the midpoint creates 2 equal segments. So the left segment needs to be the same as the right. And sure enough, it is 4 and 4. You're going to learn the formula for midpoint in the next lesson. But I'd go ahead and just kind of start knowing where the midpoint was. If there's no numbers, just kind of guess and put a point there. And then when you go to figure out the final answer using ratios or weights or whatever, hopefully you can kind of match it up. Because a lot of you were putting, like, you'd solve for the answer and you'd wind up putting the answer. So again, I'll use those same numbers, 6 and 14, and you'd go through the math depending on the weights and everything, and you'd get 8, and you'd put 8 here. And it'd be wrong, not because of where you put it, but because you did math wrong. And if you would have put 10 there first, because that's what the midpoint would have been, is 10, then you would know that 8 actually goes over here, and then you would have been able to say, wait a minute, and 8 can't be to that side if 10 is the midpoint. The answer should have been on this side, somewhere over here, somewhere in this area. So I must have done some math wrong. But again, start by putting the midpoint on there, and that'll maybe help you catch your mistakes when after you do the math and you go to put that point on the line that you think is the correct point. Again, if you're not understanding that, this is just meant to be a review. You need to get together with me or get to G2. I'm only trying to clarify some mistakes that some people made, not redo a whole lesson. I already talked about this one, but that was a big one. A bunch of people thought that, oh, well, I have 3 points on the right and 1 on the left, so that matches my ratio. It has nothing to do with that. So some people try to use numbers, which again, I told you, plug in numbers if you don't have any. Sometimes that works. It did work if you did it right. So if we want a ratio of 3 to 1, again, that's about lengths. So the point that I put on there is going to have to make the left length 3, or the left segment 3 times bigger than the right segment. So if I say this is 6 and this is 20, well, again, let's start with a median. So median is somewhere in between. It needs to make equal segments. So if I do the math, that's 13 would be the midpoint. So I can kind of start with that midpoint. Just to make sure you understand, that means that segment is 7, that segment is 7. That's what a midpoint is. Splits it into 2 equal segments. So now I could say, well, if I want a ratio of 3 to 1, oh shoot, I can't do this. Scratch all of that. Hold on, I'm not going to erase everything. I'm trying to do an example where you don't have numbers, because that's when people added that you wouldn't need to add your own numbers if I gave you numbers. All right, so now let's do this. So still visually say where you think the midpoint is. So the midpoint somewhere about here. And I would say, okay, well, let me just use numbers. I'll plug in any numbers. I'll use different numbers since I already did those. Some people, I don't remember what shows, use 3 and 1 or something like that, or 1 and 3. But I'm going to just pick numbers 3 and 10. Doesn't matter what you get. Now to get the mid, this would be a little trickier to come up with your own midpoint. So I'm not going to do it, but it would have had a decimal in it. It would have been 6.5, excuse me, because that would give you 3.5 on the left and 3.5 on the right. I don't want to get it too cluttered though. So now, if I know this is about the midpoint, actually, yeah, I am going to do it. So that number would be about 6.5, the midpoint. So now people said, okay, well, the math would be if I divided it into 4 equal sections, or if I flipped it around and did weighted averages or whatever, and you came up with a number, it would be 3 plus 30. Wait, I'm sorry. Yeah, 3 plus 30, 33 divided by 4. So 8.25. Is that right? Shoot, now I forgot my math. I said 3 times 1, 3. So 33 divided by 4. So 8.25, it looks like. So 8.25 makes sense. It would be somewhere, if this is 6.5 in the middle, this is 10, it would be right about there. Actually would split this little line segment in half. So now I can see, so that'd be about 8.25. I can see this line segment is about 3 times that line segment. So if you use numbers, it works, and you were supposed to give me which point made sense. So there was one point in the middle, which is the one a lot of you chose for some reason, but the point in the middle doesn't separate it into a 3-to-1 ratio. It would be a 1-to-1 ratio. The midpoint separates the line into 2 equal halves. The left half needs to be bigger. So there was a point over here, and you were supposed to choose the point that was correct. Well, if the length of the left segment needs to be 3 times bigger, then that would be the point that would work. If it was the weighted average problem or the using weights, again, the start with the midpoint, and that midpoint should get pulled left or right toward the heavier point. I'm gonna do one real quick. There's a lot of people miss some easy questions. So now let's say the weights were, I'll just keep it even so I don't have to change too much. So let's say the weights were in the problem, and there were no numbers. Let's just start over. Trying to rush through to make it shorter, but if you don't understand it, it doesn't do any good. So there's no, I just should have just erased everything. So again, there's a line segment. There's absolutely no numbers on it. And I gave you like 4 points on it, something like that. Well, 3 points in the middle, total of 5. And I said, which point makes sense? So if the weights were, I'm even going to put more points on there. So let's say the weight was 4 for the left point. So the weight here is 4, and the weight here is 5. Well, that means the midpoint. So first of all, I got to figure out where would the midpoint be? Well, and again, you're just estimating it, and it's not this hard on the quiz, but why is it not changing the color there? There's the midpoint. That to me looks like it's the point that's right in the middle. Well, if this is the heavier side, the heavier end point is this far right point, then this midpoint is going to get pulled to the right. Now, it's not going to get pulled way to the right because it's not that much heavier. It's a weight of 5 versus a weight of 4. So it wouldn't pull it way down here, like it wouldn't pull it to that one, it wouldn't pull it to that one. It would just barely pull it. So I would say that would be the one that makes sense based on the weights. So again, has nothing to do with how many points. And it definitely doesn't have to do with length unless you flip the weights around and then you work with length from that. But you can't just change the weights into the ratio. So the ratio is not 4 to 5. That would be incorrect. You could say the ratio, though, is 5 to 4. You could flip them around if you prefer to work with a ratio and the length of the lines, which makes sense. If I highlight it, you'll see this line is slightly longer than this line, which makes sense because here's my ratio. The left side should be slightly longer than the right side. So using numbers worked. Oh, I didn't wind up using numbers in that, but if you would have plugged numbers in, so I'm not sure if I'm going to confuse you guys more or what, but again, you need to come to me if it's not helping. So I could have started with numbers and said, well, what if this was 5 and what if this was 25? Well, plug in numbers. So if I want to solve it out, if the weight was 4, that'd be 20 plus, ooh, this is some bigger numbers. 20 plus 125 would be 145. 145 divided by 9. And again, the midpoint of those two you would have to figure out. So the midpoint would be 10 plus 5, 15. So I'll do that in red. So the midpoint would have been 15, because that's 10 from 5 and 10 from 25. So if I do the math, 9 goes into 14 once, goes into 55 6 times, it looks like. So 16.1 or something like that, I believe. So 16.1 would make sense to be that point right there. Wouldn't be this, because this number over here would be more like 20. This number right here would be more like 22 or 23. So those wouldn't make sense. 15 is the midpoint, so that can't be it. So again, using numbers works, but you kind of got to know what you're doing. And I don't think too many people that use, I think maybe one person actually explained it correctly using numbers. All right, so here's the new lesson. I didn't ever get to this. I'm just going to put it in this review video. I'm going to slow down a little bit now since we haven't done this part. And it wasn't on the quiz. But I wanted to show you. We've been assuming every time we did, it's really just for ratios. I give you A, B, and I said ratio of 3 to 1. We have all, and you're putting point C on the line. Put C on the line. So we've been saying, okay, well, the left side needs to be a lot bigger, and I'm just going to guess it real quick. So C would be there, because now my left segment, AC, is about 3 times bigger than CB. So we have always assumed we're going left to right. Well, there were some book problems that were different. They said, put point C on the line segment so that, and then it said CB is in a ratio of 3 to 1 to, I guess we'll write A first, AC. So it's actually saying the right segment CB, when it says CB first, CB is the left number. So this is CB, and this number now is AC. You always read the ratio and you match it up with whatever the first segment is. So this first segment here, CB, oh, I didn't mean to do that. This first segment here, CB, matches up with the first number there. Or you could say it's the left segment, you know, in the problem, the way they wrote the problem, it's the first segment or the left segment they talk about. So it goes with the left number in the ratio. Then they talk about AC next. So it's the second segment or the right segment. So that means actually point C, because CB needs to be longer, point C would actually have to go way down here to make it something like that, probably. So now CB is 3 times longer. So again, we always assumed that we were always talking about the left segment first and then the right segment. But in the book, they gave you some problems where they mentioned the right segment first, like this example right here. They talked first about the right segment CB, then gave you the ratio, which means the first number is the number for the right segment, not the left. I'm not going to spend any more time on that. If you don't get that, the only time it would come up again is on the district cycle tests or your midterm or for your EOC, your final. So just remember when you're talking about ratios, make sure you think about which line segment they're talking about first, and that's the line segment that would match up with the first number in the ratio. And lastly, I'm going to do an after-school tutoring session on Thursday. So that'll be not the day we come back to class, assuming we're coming back on Thursday. That'll be the following Thursday. So the Thursday after Labor Day. So it's not for me to teach you how to do an entire lesson. I will not be able to do that, especially if there's quite a few people in there, which there normally aren't a lot, but even with 4 or 5, I can't sit there and redo a lesson for one person. You need to practice. You need to watch the review videos like this one. And the other review video on points, lines, and planes is already posted. You need to watch those, try to do some problems, and come in with questions. If you come in and you ask me to redo a whole lesson, I won't. I'll tell you to watch the videos while you're in class, like while you're in the tutoring, and then to come to me with specific questions on problems. I don't have time ever, even in tutoring, to do a full review lesson of one topic. So I need you to come to me prepared with some questions on things you don't understand, specifically on problems you couldn't do. That would be the best, but I can't do every single problem and I can't redo a lesson. If you need to do that, you need to go to G2 every single day. All right, so come to me if you have questions after you watch the videos and practice problems, and the tutoring will be from 2:30 to 3, I'm sorry, from 2 to 3 p.m. Thursday after Labor Day.